Now here in this video we're going to look at the inverse cosine function. So before we do that, just like we did with the inverse for our sine function, I want to look at the cosine of x, y equals the cosine of x. And just like we said before, in order for our function to have an inverse, it must be a one-to-one function. So once again, if we look at the cosine function, and I'm going to go to zoom trig, and we've looked at this before, so here's the cosine, and clearly it does not pass the horizontal line test, so it's not a one-to-one function. So what that means is, just like the sine function, we're going to have to restrict the domain. So how can we do that so that we will end up with a one-to-one function so that this will pass the horizontal line test? So we know that we have the cosine function. If we think of this graph, we can start at this point here and go down and then back up. Oops, that's too far. We would start here and go down to this point, because if we stop here, this part of the graph now would be a one-to-one function. So we're only going to look at this graph from 0 all the way out to pi. So what we're going to have to do here is, for the domain, we're going to restrict the domain from 0 to pi. So we're going to go from 0 out to pi. And then the range, and see if you can figure this one out. Well, once again here, the great thing about going from 0 to pi is we're still going to get out the range of 1 and -1. So here the range will be -1 to +1. So even though we're restricting the domain, notice our range for the cosine function is not going to change. So by doing this, we now have a one-to-one function. So if we look at this closely here, we now can look at the graph of y equals the inverse cosine of x, which means our domain and range is going to be switched down here. So that means the domain of this function would be the range of what we had up here. So the domain is -1 to 1, and then the range is going to be the 0 to pi. Okay, so here when we think of this in terms of the unit circle, again, for me, a visual here, that means we're looking at the answers that we're going to get from this. When we plug in a value here and we take the inverse cosine, the only answers that we can get out would start here at 0 and then go over here all the way to pi. And again, this is looking at the range 0 to pi. This is not the graph. The actual graph of the inverse cosine function, so if we look at the graph here, we're going to go from -1 to 1, and then we're going to go from 0 all the way up to pi. So this point here would be pi over 2. And if we were to look at the graph is going to look something like this. It's going to start here. We could look at it curving this way and then curving up like this. So again, we're kind of looking at this part of the graph as the cosine, and then the inverse cosine is going to look like this. And keep in mind, we're switching the domain and range. So up here for the cosine function, where the domain is 0 to pi, that's the range down here. So on the y-axis, we're going from 0 to pi. And then up here, when the range is -1 to 1, that's going to be the domain for the inverse, going from -1 to a +1. Now again, this is the graph of the function, and we'll do a little bit with the graph, but visually what I tend to think of with the inverse cosine is the only values that we can plug into this are from -1 to 1, and the only values that we can get out are from 0 to pi. So that basically means when we take the inverse cosine, and we'll look at using the calculator here in a little bit, our answer is going to be somewhere from 0 to pi in the first or second quadrant. Okay, so that's what we're looking at when we think about the inverse cosine. So for an example, if we had a problem and we wanted to look at finding the inverse cosine of 0. Now keep in mind another way to write this. Remember we talked about the arc sine, so we still could write this as the arc cosine of 0. So this arc cosine is another way of writing this. So if we want to find this here, we're trying to find this value, the inverse cosine of 0. Well, that means if we were to go the circle here, the cosine is our x value. So what we're saying here is x is equal to 0. And we're trying to find here what is going to be the angle that has an x value of 0. And when we do this, based on the diagram up here, our range, it has to be somewhere from 0 to pi. Okay, so that's where here the inverse cosine of 0, well, where is the x value 0? Well, if I was to mark this off, we have here x is 1, 0. Up here at the top of the circle, we have x is 0, y is 1. And over here, we have -1 and 0. So what that tells us, if we're looking for this angle, what angle has an x value of 0? Well, over here we have our x value that is 0, and the angle at this particular location is going to be pi over 2. So therefore the answer is pi over 2. So once again, the other part of this problem is anytime you use this inverse cosine or arc cosine, that means that we're looking for the angle that gives us, in this case, an x value of 0.